Friends, hello everyone. On the air, Ivan Juravlev and Anton Zelensky are on the channel about the MoleculerJS framework. Ivan will tell us about it today. But let me, with your permission, introduce Ivan, who is currently CTO at Token Place. This is actually not the first company in which Ivan actually has experience in the combat operation of the framework, which he will tell us about today. Ivan and I talked and found out that this is the fifth combat project where this framework is actually used. This is actually quite a lot, but even more interesting is that 3 of these 5 are still alive. That is, these are startup initiatives. If any of you have ever participated in startups, I willingly hope that it is. You probably know that in general, when we say the word startup, we kind of mean that it won't last long. Statistically, startups are a very short-lived thing. Well, at least that's what the statistics say. And actually that 3 out of 5 startups started on this project are still alive. I do not know what it is, that is, it is absolutely such an outstanding result. Maybe Ivan is a wizard, maybe some kind of magic framework, maybe there is a place. Some kind of composition of these events, one way or another, has developed quite high. I will add to the miracles. Another interesting aspect turns out to be one of the projects that Ivan launched on MoleculerJS, passed an external audit. Am I right? Yes, that's right. Such a story. And an external audit, if any of you participated in this, it's actually quite a painful story because people who are deeply competent and who are absolutely not motivated to protect you somehow come to your project. They are not on anyone's side at all. They just usually work out quite a lot of money and dig up everything to the very depth, and as a rule, they are not that destructive audit results. This is not always the case, but they generally say so right there uncut. If there are problems, they write about them directly. And actually, according to the result of such an audit, collected on the molecular framework with the participation of Ivan under his leadership, an audit was conducted. This is also really a big milestone, a big deal. Do you think, Ivan, we will be able, today, to avoid talking about how the monolith is worse than microservices or better than microservices? I think it will not succeed, but we will leave it all for discussion time. It seems to me an eternal theme. Yes, but in fact there is still, if anyone does not know, something in the middle, probably the most common solution in fact, hybrid architecture. We will touch on it a little today, too, as far as I understand. A few words about yourself. My name is Anton Zelensky, I work for EPAM Systems. My position is called Chief Software Engineer. I participate in projects that are complex, some kind of wrong, where deep digging is required, where a lot of engineers are required. Some kind of fast delivery to the market in a short time, very complex projects are my specialty. I've been working on the front end for the most part lately. If you can very persistently Google my story about the reincarnation of microservices at the front, so it's called microservices at the front. After a while, a new correct word for this approach appeared. In my opinion, it sounds micro-frontends. Well, before that, I also participated in projects on back-end architecture and in back-end development, and of course there were microservices in the architecture, including. So I have a little experience in this regard. Such things. Ivan, we can probably move on to the report. Yes, let's give you the floor. Welcome. Hello everyone, my name is Ivan Juravlev. I am 34 years old. I have been developing for more than 15 years, 8 of which I am engaged in the architecture of distributed and high-load systems. Among them are social projects, the industrial sector, and the blockchain industry. I have 2 patents. In my free time, I contribute to open source projects. And today I will tell you about one of these. Over the past 3 years, as Anton already mentioned, I have developed 5 projects on the molecule, 3 of which are successfully working. I will tell you about 2 of them at the end of my report in more detail. I have been in the main team at the Molecular since February of this year. I am engaged in localization of documentation to the Russian-speaking community in the Telegram, by the way. Join us, there will be links at the end. Bugs and user maintenance. I am now helping core developers to plan the architecture of the framework in subsequent versions to fix some shortcomings and improve what is there. Now we will talk about this architecture in more detail. Let's start with a simple. I would like to clarify what a service is and what a microservice is so that we can continue to have a complete understanding of how the architecture works. Service-oriented architecture. This is an approach to development in which each service has little connectivity between other services and they share the responsibility of business logic among themselves. We can pack all these services into one image and deploy them on the server as a monolith. Microservice architecture, on the other hand, is an approach in which we have a single application built from a variety of poorly connected smaller services. It is these services that we talked about in the previous slide. They support independent deployment, which allows us to scale them horizontally. On the slide we see what it looks like. That is, we have every service now in an isolated container. But the most interesting thing is mixed architecture, or else it is called hybrid architecture. It allows us to build sets of services in such a way that their interactions with each other are built as efficiently as possible. For example, these are posts, users and comments we packed in one container. Thus, it allows us to display posts, comments to each post and the authors of these comments as quickly as possible. We also have replication created here. That is, if, for example, 5 nodes are unavailable, then 4 nodes can always process a request from us. If these services are separated and requests are between different nodes and services, then it will pass through those nodes that are currently available. I'll tell you about it in more detail. The framework is very flexible. It allows you to use any of these architectures, quickly switch between them without changing the code. Let's start with what exactly is a molecule. It's an open free fireworks display on Node.js. It provides a set of tools for writing distributed applications with flexible vertical and horizontal scaling. Through the mixed architecture, which I just told you about, let's take a little closer look. The molecule is a broker service. It is a set of tools that contains basic components that allow you to close the needs during product development. At the same time, it allows you to solve fundamental problems that you might not even think about at the initial stages. So, let's talk about one of them, of these components. Caching allows you to cache both the entire responses of the service and some selective data inside your business logic. By default, it happens in memory, but we have to stick to stateless, so we use Redis, and for distributed locks we use redlock. Another basic functional is logging, which is presented to console output by default. It is also possible to connect one of the supported external adapters. For example, we can collect Prometheus metrics. Oh, please excuse me. An external adapter, for example. We can use Datadog, send logs there. You can also use several different adapters. That is, we can output both to the console and send logs to Datadog. There is an opportunity to write our own custom adapter. There is an example of a basic skeleton. How it is done. Metrics and tracing, they also have a console option by default, writing to a file. You can also use an external one of the supported adapters. That is, we can collect Prometheus and traces in Jaeger, then it's all displayed on one dashboard. And look at Grafana. You can also use several. For example, we can output to the console and send to the same Datadog, if necessary. It is also possible to create your own custom adapters both separately for metrics and separately for tracing. Another bonus is that the free framework provides you with the opportunity to create business metrics and traces of your business functions. There are major downturns and actually all the necessary functionality in order for them. Manage. So what is it good for? Easy to learn, fast, convenient to work out and debug, has many solutions out of the box, it scales easily and is suitable for experienced developers, it has a developed ecosystem and community. What does the simplest microservice on the molecular framework look like? Let's create a broker, declare it, create our instance, it will manage our services and provide them with access to the built-in component. Let's add the first service and call it math. There are actions in it. With actions, we will declare a single add in which ctx is passed as the first, only argument. This is our context. I will tell you a little more about it later. From the context, we get the parameters a and b with which we perform the mathematical addition operation. Now let's launch our broker together with the service. After it starts, we will call our service by specifying the name of the service, the dot and the name of our action, and with the second argument we translate the parameters a and b, respectively, for additions. There is also a third argument that allows us to pass the settings of this request. For example, if we want to access a specific instance or we need to set a timeout or some additional processing. The result of resolve promise will be the number 8, the result of the complexity of our numbers. It is also worth noting that the services support versioning. We can specify inside the service, for example, that this version is 1 or 2, and then we will have access to the service in the first argument as 0:11:57.450, 0:12:01.690 service prefix.v1.service_name.action_name, service prefix.v1.math.add. So, well, I hope that you have already been bored and it's time to dive deeper into technology. Thanks to William Echo for the illustration. How do our service brokers turn into microservices? They need transport by which they will communicate with each other. The exchange of messages and the transport of the molecule takes place via a built-in protocol that we also develop and support. To begin with, service brokers agree among themselves what version of the protocol they have, what they can do, and so on. And accordingly, all messaging takes place through this binary protocol. Also above it there is a layer called transit that allows us to use different types of middleware, including you can write your own, from the standard ones, from the built-in ones. This is compression. Traffic encryption, middleware can be implemented using hook events, so-called on transport and protocol. So what kind of transport does the molecule support? Is cloud-native TCP. Inside the Gossip protocol NATS is used. We use it in combat. It is a highly productive enough solution, also cloud-native. NATS is connected to all our projects, and there is also support for Redis, MQTT, Kafka, AMQP. The ability to implement your own protocol, there is no difficulty in this either. There is a skeleton that allows you to familiarize yourself with the methods for implementation. Let's consider how they communicate by transport. We have two components. This is discovery. How do they detect each other by transport? And registry, how do they store information about where which service, action, or event is available for calls on which instance, how many instances of them and on which nodes. Each service broker stores all the information about registry in memory inside its service broker, and they update this information according to the protocol. Another tool that allows you to build distributed services is request balancing. Since the service broker already has information about which nodes have which services, it has built-in balancing strategies and it can choose which service it should send this request to based on the settings of the balancing strategy. The strategies that are now supported out of the box are, in a circle, all available standard round robin. In random order, or by latency, processes, the one with less network latency. According to the CPU load, the one who is freer handles it. We also have sharding on some basis. For example, by the user's country, we can, in connection with the legislation, divide data storage. Most importantly, balancing strategies can be redefined within each service. That is, if we want to choose a general balancing strategy, like round robin, and install sharding for a certain user service, then we declare it directly in the service and configure it. You can also write your own balancing strategy. Also, all the necessary methods and examples are available for this. And so, in addition to balancing and transport, we also need serialization. Now we will talk about it in more detail, because this is one of the important things for distributed systems. Why is it needed? This is a simple way to bring our data structures from the code into some kind of string or binary form. The molecule supports standard JSON, MSG-Pack, Node-Pack, Avro, Protobuf, Thrift and CBOR. Its own implementation is also possible. For example, we use CBOR in our company. This is the most effective. I'll tell you about it now. Serializer, which allows you to interact between the nodes of the molecule. Exchange information and transfer data to WebSockets as a client in large volumes and very quickly. So how does serialization work for us? We store data if it is a JSON stringify, structured, then null will occupy us as a regular string of 4 bytes. That is, each character takes up a byte. For example, consider the same with an array. We have parentheses and there is a value of 20, it will also take 4 bytes. At the same time, in the same MSG pack, we get null as 1 byte, it's just the type of value. We serialize the array as a structure. 91 responds that it is a fixed-length array serialized from 1 element and 14 in hexadecimal representation is the digit 20. With the rest of the serializers, the principle is exactly the same for data serialization. That is, we store the data type, the length of the value if it is required, and the value itself in binary representation. So that's the most interesting thing why it's needed. Serialization has 2 criteria. This is the compression strength as far as we get a large size. Outgoing packet and serialization speed as we see from above. We have the payload size and JSON output. It turns out to be 169 bytes. This is the same JSON stringify that most. Probably the least of you use this Avro 88 is almost 2 times more compact, but there is also a speed that greatly affects the operation and blocking of our event loop. JSON has 335,500 RPS compared to CBOR, which has 570.7 thousand RPS. CBOR gives us a 70% increase in speed. We have such a non-optimized JSON.stringify. CBOR is much more optimized, but it gives less profit on data compression. If we are interested in speed, we naturally choose CBOR. If we are interested in large amounts of data with maximum compression, then choose Avro. There is also one small nuance. I conducted this benchmark on 10 bytes of data. At CBOR, with a larger data size, a smaller profit is already given. That is, it will fall with the size of the data, but nevertheless, even with 1 gigabyte, it will not be lower than that of JSON.stringify. Why do they need microservices, these contexts, and how do they work? When calling any service or event, our service broker creates a context in which it records all information about this request, who is calling it, who is called by the unique request ID parameters metadata parent context if there is one, and the nesting level, as well as data for tracing. Using contexts, each service or event that it receives can add some information and pass it on to the next service. The last service that receives this context, it will know all the passages of the entire chain between the microservices will know what is written there now in this context to receive all the relevant information. For example, how it works. A request came from some business logic. We have to process the request of an authorized user first. We received a JWT token in one service, pulled some kind of identifier out of it, passed it to which service of the user there, therefore. We received information about the user from the database and then passed it all in this business logic, well, or checked some other permissions of this user. And between each request, we add user information to the context so that our last service does not broadcast business logic has already received all the information in this context. The user could not know who we are contacting and what actions we are doing. An even more important point is its stability. When we have a large chain of services with a bunch of nested calls, we need to ensure that these calls reach the endpoint and return some result to us. The distribution of the architecture is used in principle, for the most part, similar to the failures of stability, as the same ones are used in a conventional elite solution. Trolling is a story. Even the same timeout, but in certain systems it is a certain timeout, it works a little differently when each subsequent service transmits. Request he wins the execution time of his logic from this timeout. If initially the timeout is 5 seconds, the service has worked for a second, then the next service is already being called with a timeout of 4 seconds. If he does not have time to process the request in these 4 seconds, the timeout error will return. This is how the timeout works. I'll tell you about a few more interesting ones. For example, it was a hit that sets a strict limit on competitive requests to the service. It has 2 modes of operation. It can request requests that come in excess of the limit and put them in a queue and process them from this queue. But the queue has been eliminated. We can't do this on the queue, otherwise it could lead to a memory leak. The queue has been eliminated. We may also get an error that the queue is full. Or the second mode, when we can immediately discard requests because we know that the service is capacious and it is not worth overloading it, and we can simply discard this request. There is a more interesting smart solution called bridging. It allows you to protect on the highway from a single failure, and in the case when one of them cannot cope with the load or is unavailable, it allows you to temporarily disable it. As this mechanism works now, I will explain to you. When we have this chain of calls between services and some service, for example, goes into timeout for a long time, does not respond, and the requests that come to it, they all fall by timeout error. At this moment, Boyko turns on. He determines that this service issues errors more than a certain limit set on construction sites and simply disconnects from it, thereby allowing these requests to be balanced, for example, for its publication on another instance. After a certain time interval, the KGB skips some request, looks at whether it was successfully completed or not on this service. If errors continue on requests, then we are waiting for the next interval. If the service has collapsed successfully, it skips another one and thereby gradually includes it in the work. If the error limit is not within the permissible limits that are set at construction sites, in fact it is a machine that works with services and turns their state on-off. Automatically, the molecule allows you to flexibly figure out the parameters of all the considered patterns of stability failures. So she supports every one. Let's move on to the next problem, no less important. When we send an event, for example, our user has registered, we have sent an event that a new user has registered in some mail service. Postal. We caught this event and have to send an email about the registration of users we have little to do with. And then there is the problem of guaranteeing the delivery of these messages. Suddenly at some point we had a local network, or I don't know, they blocked the GDP and the service did not receive this message, could not process it. In fact, it is lost forever. For such moments there is a solution that with guaranteed delivery on the 5th one or more times. And it also allows you to additionally use such stuff as posting messages when we cannot execute the same message several times. How it works. There are solutions on the basis of which a package of molecules has been developed. This is in the Kafka register. Everyone knows. And there is also such a solution as National Jet Stream, which is a completely new solution to replace the market. In an ideal world, it is assumed that all messages in the queue always end up at the endpoint, but in fact this is true only in the only case if, when performing the task, all possible mechanisms of state and conflict resolution for exits from these states are implemented. In the real world, there is such a plowman as Dale queue and a queue of undelivered messages into which such messages fall are waiting for human intervention. The scientist's molecule supports the patent and does not allow these messages to get lost, the state of which could not be processed inside the task. Let's move on to the next one. The molecule has two solutions for working with the database. Even without them, the molecule is an older solution tested. It supports a large number of databases already, and there is it. A new reinterpretation of the version of the accident that appeared in principle recently, less than 6 months if my memory serves me right. This package allows us to describe the data model that we have to create were embedded in the molecules and use different chips of the embedded molecule. Protection of answers. When we requested a list of users and the answer to this order broke out, and since we have a device that allows it to be distributed and works, it can still support out of the box. If we announce this data, then the rest of the instances reports about that. Of course, you need to clear the data so that they can be taken from the database in the next request. But there is also, for example, a speed to which you can subscribe this data change. For example, if we know that when we change the user's password, we have to perform some action there in some service, we can subscribe to this event. In the world of microservices for working with databases, there are 3 main design patterns. Molecular supports 2 of them, supports all 3 of them, but specifically MolecularDB and database supports 2 of them. This is the first one, the database for the service. A tabled collection per service is a standard pattern of microservice design, but there is also a pattern when we have a common database. I work with this pattern. We have implemented a separate middleware based on Nex, of which I am also a contributor, and we use it. I will tell you further why. There are a number of problems in distributed database services. Why did I choose a shared database, although it would seem that someone might call it an anti-pattern? In fact, this is exactly the same pattern that works and that solves problems such as distributed transactions, multiple database connections. If any of you have heard such patterns as Saga, how they work, or even better, if you know what chaos engineering is or have heard how databases pass the Jepsen test, this is exactly. I will not be able to talk about the problems associated with distributed transactions in this report. A whole separate report is needed about this, because Saga is not a solution that could compete with distributed transactions at the level of specialized databases. I will tell you more, for example, about Jepsen tests. This is just testing, which allows you to come to such cases when the database cannot execute a query. For example, some kind of failure occurred in its different systems and a transaction. It cannot be completed successfully, and so Jepsen testing allows you to create such tests and see how the database behaves. The same testing should take place for patterns such as Saga, transaction log, which is used on top of Saga in order to control. Saga itself can be orchestral or I forgot the name. So, at the moment there are a number of architectural nuances that are still being discussed in the scientific community about how best to solve them. Choreography and orchestration, I remembered. Let's move on. In addition to everything described earlier, we do not forget about the developers who work on local machines. For them, we have prepared a separate package, APN Lab, which allows you to explore and debug the molecular project directly on the local machine without having to install or configure a full-fledged environment. Let's look at what it is. In it you can see a map of all your service brokers, how they are connected to each other. Everything is beautifully shown there, the availability and unavailability of any service brokers, what traffic between them passes through transport. There are general techniques where the status of services, actions, events is displayed. From above you can see, it signals green or orange, it means the presence of replication. The fact is that in microservice and distributed systems there is a replication factor for fault-tolerance data. Usually it is n+2, that is, we must have at least 3 active instances. This is a sign of reliability. You also have a visual trace available that demonstrates how long and how the call occurred between microservices within the same request. This information is collected distributed from all instances and is constructed in the form of a graph by, as previously mentioned, request ID transmitted in the context from one call to another and additional data. You can also collect logs to watch from each instance. They all flock to a single interface. You can search for them. I recommend on production so that you have minimal logs. Keep in mind that they affect performance very much. The recording of these logs needs to be remembered and where without the most important thing, speed. The framework constantly strives to be as fast as possible. The benchmarks results of each component of the framework as well as the benchmarks code itself are available in the repository and documentation. You can download the source code yourself, go to the benchmarks folder, and test how your system will work on your source data by editing them. It is also worth noting that in the Molecule there is also a Molecule REPL package that allows you to launch your project in the console and use the bench command to test this or that action. How does your business logic work out whether you have narrow necks in functionality? Over the years, the framework has been overgrown with an ecosystem from all sides. There is awesome with a lot of materials and modules. It is worth noting separately the presence of framework implementations in other programming languages. Thanks to the community, it is fully supported by almost 5,000 stars and their linear growth is visible on the chart since 2017, 27,000 downloads per week and NPM over the years. Many projects developed on this framework have appeared. You can read more about all of them in the pinned issue of the official repository. Let's see what is happening in Russia with the Molecule in Russia. The well-known car-sharing Delimobile uses the Molecule for internal services. 2 more projects developed by my team, which I mentioned at the beginning of the report. The first project is a chatbot developed for UNESCO with the support of VK, Eli for teenagers about the physiology of growing up, relationships and sexual health, and the third project is the Integrity Project. The system of protection against counterfeit of long products is now being implemented at cable enterprises throughout Russia together with the Association of Electric Cables, and it is worth mentioning that one of my patents has been obtained for this technology. You can find about all these projects on the internet by name and read a lot of articles and information there. Another funny fact is that Ghost developers use Molecular for orchestration and billing platform and left thanks about it, noting that they receive new useful knowledge. Learning the framework is all about it. Thank you all. You can scan the codes and go to the questions. Ivan, it was cool. Thank you very much.
Иван, это было круто. Спасибо большое.
I looked at everything carefully and was once again surprised at the depth of the study of many cases that engineers have in real life. Of course, I wanted to use the right of the first, but I will not take such courage. I see a question in our Telegram chat and I'll start with it. Sergey Ivanov asks, is it possible to add a service nearby in another language and implement its own protocol into a set of these services there? If it is not one of the languages that are already supported by the community, that is, they already support the protocol. The protocol is not the only communication with external services. We have a package called Sidecar, which allows using the REST API to connect an external system to the infrastructure of the Molecule in the ecosystem. External services will register in the same way as internal services. They will be able to receive hooks events and requests will be sent to them via REST API. They will also be able to access any services via the REST API. Thus, it turns out that you can write on anything if the service meets the specification of the system, namely global monitoring, tracing and all these important things. All this will work perfectly. Yes, no problem. That's right. Sergey, I hope we have answered your question. If not, please switch to Zoom. One more question from me and we will go into a discussion that we will be able to talk about everything in detail. I have one general question. Tell me, please, still considering how many I just see 8 alternative options there for serialization, deserialization of 8 options for custom mechanics transports, and it all looks like an absolutely production-ready solution. But on the official page of the framework itself, as far as I understand, you are its maintainer among maintainers. Yes, yes. It says that we are not in the release yet. Wait, we will do it sometime. Why? In fact, this has happened historically, even more so. Sometimes the community reports about why it is written in the documentation there that this is some kind of unstable version, when it has been moving from version to version in the documentation for a year already. I think that this is a lack of time to update the documentation. There are not enough resources. At the same time, the framework itself from the 11 version 0.11, I think all versions 0.11, 0.12, 0.13, 0.14 are already in production. They are all production ready. They have a small number of breaking changes. I think this is a historical versioning, and I do not even know when we will come to version 1 at such a pace. We can classify your answer as call for volunteers. Yes, if someone is ready to contribute to things that are just not enough to officially release, if there are such guys among the listeners, where to put an excess of your enthusiasm. Then there is a very useful thing. Get involved and you will be honored and recognized. I'm sorry I interrupted you, Anton. I think perfectionism is more influenced here. Because all the maintainers who are now in the core team, they want the best, the perfect solution, and they are afraid to call it a stable version of some kind. I read somewhere that perfectionism is a form of procrastination. But I hope this is not our case. Friends, in fact, there is still a whole set of questions specifically for me. Maybe someone else from you will appear, and it will be interesting for you to ask them in our discussion. She is in Zoom. I really hope that the link is available to you. Switch, please. Let's go there and talk in detail about all sorts of curious cases. Thank you all.